Hello everyone, welcome to my YouTube channel. So today we are going to discuss a matrix method, which is basically called the inverse matrix method. So this method can only be used for the system with a unique solution, where the coefficient matrix is scarce and invertible. And this method will apply for the two variable linear equation for 2 order 2 matrix or maybe 3 order 3 matrix. So in this video, we are discussing the 2 order 2 matrix, and in the next video, we will be discuss for the 3 order 3 matrix. So that will be start with the basic formula, which is about the A x, which is equals to b, and to find the value for the x, which is like based on the variable, then we need to do the inverse of a. That is the inverse matrix method. So how we can apply for that? For that we need to firstly like form the matrix, which is a basic step, which is the first step for the inverse matrix method. So I'm taking a random example for that. So the system I'm taking, it's 3x plus 5y, which is equals to -7, and x -3y, which is equals to 7. So I'm taking these two equations and we need to form the matrix, right? So for this is like A, we have 3, 1, and 5 and -3. And then x we have x and y. And then we have B, which represent the -7 and 7. So now this is about the step first, and next we have the step second, in which we need to find the inverse of A. So to find the inverse of A, like to calculate deter like to find the inverse of A, we need to calculate the determinant. So how we can do that? A we have, and this is a 2 order 2 matrix, right? We have 2 rows and 2 column here. So this is the basically means for the 2 order 2 matrix, so which is called 2 row and 2 column. So for this we need to find the determinant of A. So how we can find the determinant of A? We just need to multiplication for fourth element with first element. So which is 3 into -3, and then negative in between that, and multiplication of second element with third element. So it's like we have -9 and -5, which becomes -14. So now after that we need to find the adjoint of A, because to find the inverse of A, there's a formula which is determinant A and adjoint of A. So to find the adjoint of A, there is a formula for that, which is I'm using D -B -C and A. So this is based on the cofactor and minors, how to find that, and that we will discuss in the next class maybe, or in any other class. So for now you can use this formula to find the adjoint of A. So for that, now we have matrix which is A, for like D we have here, it's like, so this is -3, and then we have B, which is 5, and C, we have 1, and A, we have 3, right? So for this, it's like A inverse, we have 1 upon negative 14, and for adjoint of A, D, which is negative 3, and B, which is negative 5, and C, which is negative 1, and A, which is 3. And now we need to multiply it with B. So A inverse B. So A inverse we have already, which is 1 upon negative 14, negative 3, negative 1, negative 5, and 3, which is multiplied with the B. So B we have negative 7 and 7, right? So for now, it's like here we have B. And we need to put in the almost last step, which is negative 7 and 7. So now we just need to multiply this row with this column and then again this row with this column. So I'm doing first element negative 3 with negative 7. So we have 21. 3 into 7 is 21, right? And then we have negative 5 and 7, which is negative 35 because there is a negative between them. And then we have negative 1 with negative 7, which is positive 7. And then we have 3 into 7, which is 21. So now we have 1 upon negative 14, which is 21, negative 35 is negative 14, and 21 plus 7, which is 28, right? So now all these equals to x, right? Because A inverse B, which is equals to x. So x we have negative 14 over negative 14. And then we have 28 over negative 14. So which means we have 1 and negative 2. So now x we have, which is for the variable x and y. And now we have two values also, which is 1 and negative 2. So the value for the x is 1 and value for the y, which is negative 2. So we have two values for the two variable. So basically this orientation in two lines intersecting at a single point, and the system has a unique solution, which is x, which is equals to 1, and y, which is equals to negative 2. So this is the whole method for the inverse matrix and how you can solve this. In the whole matrix method, you just need to find the inverse of A for the very first step, which is determinant. And after that, you need to find adjoint of A with a basic formula that I used here, but we can do the minors and cofactors also in any other video. But this is the basic formula that you can use to solve the like easily in your exams, or you can directly cram the formula for fast calculation as well. So then after finding the A inverse, then you just need to multiply it with B. And after solving A inverse B, then you can find the value for the variables. So if you like my video, please subscribe my channel and press the bell icon so you can get the another video for the order 3 matrix. Thank you.